something important I want to point out. If you draw a graph of y equals x to the power, sorry, if you get a graph and draw y equals 10 to the power of x, you will get this red line here. Now, remember from our section on functions, if you have an inverse, it's the inverse of whatever function, it will be a reflection along the y equals x line. Okay, so if you reflect this along the y equals x line, you will get this. You will get this. So yeah. So this is our y. This is our y equals 10 to the power of x. Now, if you reflect this along the y equals x line, you will get this blue line. Well, this blue line is log of x. So what I'm trying to say here is that this is our original function here. And because this is a reflection along the y equals x line here, this blue line is actually the inverse of this red line here. So what's happening here is that you can imagine as this. This 10 to the power of x, it is a function. It's a function here. And log of x here is also a function, because remember what a function is. A function is like a graph that doesn't go back on itself. So this is not a function, because if you draw a vertical line, you will get three outcomes. So yeah, so you see this here is a function, this here is a function here. So whenever you have y equals 10 to the power of x, the log thing is the inverse of 10 to the power of x. So you can imagine it as being like this. So 10 to the power of x is like a machine. If you put anything into here, let's say you put z into here, you would get, let's say you would get whatever out here. Now, if you put the whatever back into the log here, you're going to get back to your original value of z here. The point is that this is the inverse of this, and this thing here is the inverse of this, and you can see that on the graph here, because it's a reflection. This here is a reflection of this, and this here is a reflection of this along the y equals x line. Okay, so they're the inverse of each other, and the thing is, the reason why we don't have well, don't forget, when you write log x, you automatically default it to the base 10, and the reason why we have base 10 and not log to the base 7, there's no button on your calculator for log base 7 or log base 2 or log base 3. The thing is, we don't need all the others. We only need one, and that one, let's choose it to be 10, because if you look at this formula here, you see when you have log to the base a, well, a could be anything, and then this thing here will work. Now, if it will work for the base of anything, let's just use one. Why create so many, like 3, 4, or 5 log base 10 or log base 7 or log base 8? Just stick to one log. Log base 10 will do. With one exception, and that's log base e, whatever e is. So we've only got one button, log base 10. We don't need log base 3 or log base 5, but there will be one where you have log base e. But don't worry about this. This is for another time. Okay. But the point here, the important thing is that this is the inverse of this, and this is the inverse of this. Okay.